Now, just like how we have a property of equality for exponential functions, right? How to solve for x for if they're equal to each other, our functions. We also have a property of inequality for, or property of inequalities for exponential functions as well. So I can also solve it if I have a less than or equal to sign, a greater than or equal to sign, or just the greater than and less than. So let's go ahead and define the conditions here. So remember that an exponential function takes on the form b to the power of x. And then let's say, so let b greater than 1, then we have b to the power of x, oops, not equal to, but greater than y. Greater than b to the power of y this time, if and only if x is greater than y. So it's similar to the equals, right? Except this time I'm putting the inequality sign. So if b to the power of x is greater than b to the power of y, then this implies that x is greater than y. Right? This means that x is greater than y. Probably not implies. Alright, so and then likewise, what if the inequality is the other way? Then we also have b to the power of x less than b to the power of y, if and only if, now it's the other way around, x is less than y. Okay, so let's look at an example. An example that we have, so let's say we have 2 to the power of x, and this is greater than 2 to the power of 6. Well, then this means that I have x is greater than 6. Okay, so in the context of solving for x. And then similarly, if we have 2 to the power of x, that is less than 2 to the power of 6, then I have x is less than 6. Right, so now let's look at a more complicated example. And this time I have 5 to the power of 3 minus 2x, and this is all greater than 1 over 625. Right, so we looked at it if we just have the same bases. Now what if I have something crazy that looks like this? I don't have any bases. I don't know what's going on. But anyways, alright, so and they're trying to tell you to solve for x. Or try to find, like those boundaries where the answers could possibly be. Right, solve the inequality. So, well, 5 to the power of 3 minus 2x, I can keep that the same. How much I can do there. And then 1 over 625, well, 625, either use your calculator, whatever is at your disposal, to figure out where 6, well, we know it ends in 5, so this is obviously going to be to a power of 5, or we have factors of 5. And then if you calculate that it's 5 to the power 4 is equal to 625, well, then you have 1 over 5 to the power of 4 here. Now, the power of 4, 5 to the power 4, is in the denominator, so this also means, alright, so if you will recall that if you have 1 over a to the power of n, this is nothing other than a to the negative power of n. Alright, so this means that I have 5 to the power of negative 4 on the right-hand side, and I haven't touched the left-hand side yet. That still stays the same. 5 to the power of 3 minus 2x is greater than 5 to the power of negative 4. So now, what this means right here, right now I have the same bases. So just like the property of equality for exponential functions, your goal, when you want to solve for x, your goal is to have the same base. You have the same base, you can work along from there. Okay, so we have the same base, which is 5, so now this implies that our powers are now equal, or not equal, but greater than. 3 minus 2x is greater than negative 4, and now I can get x by itself, so let's isolate x. So it's minus 3 on both sides, so we get negative 7, and then I have negative 2x, and I'm going to come up here. So I have, what is it, negative 2x greater than negative 7, divide by negative 2. Apply the rules of inequalities as well. When you divide by a negative, then you have x is less than 7 over 2. And then this would be your final answer right here.